All right, so we just watched, or you guys probably just watched the video over what a half-life is, and so I wanted to kind of walk you through step by step how to do some half-life problems before I set you loose on your own, since I really couldn't do them in the PowerPoint. So first of all, I just kind of want to review a half-life, which again you guys will see, this is how we shorthand it, T with a subscript 1/2 to represent half-life. Just to kind of reiterate what a half-life is. Half-life, don't think of half-life as an amount of time. Think of it as an amount of substance. So if we look over here at this graph, if we start here, this is your percentages. If we have 100% of our sample, look down here, the number of half-lives. So we've gone through 0 time. You're going to have 100% of your sample. And if each one of these lines, as you go across, is representing the half-life, if you notice, as you go down, half of your amount exists each time. So if we only go through one half-life, which would be right here, we're going to have 50% of our sample left. If we go through 2 half-lives, we should have 25% of our sample left. If we go through 3 half-lives, we're going to have 12.5% of our sample left, and it just keeps getting smaller and smaller and smaller. So, but this is with percentages and not with amounts, so we're going to go through some practice problems just kind of showing you how and what the easiest way is to go about solving these half-life problems. So I'm going to do 2 of them, then I'm going to have you try one on your own. So the first one I want to look at is involving cesium. It says the half-life of cesium-137 is 30.2 years, so that's how long it takes for 1/2 of our sample to decay. If the initial mass of the sample is 1 kilogram, how much will remain after 151 years? Okay, the first thing I do is I kind of list my variables so I know what all of these numbers are. Because for whatever reason, we always get these 2 numbers confused. We don't know which is which. So our half-life is going to be equal to 30.2 years. Okay, this is our total time, 151 years, and our original amount is going to be 1 kilogram, and we want to know how much is left in the end result, so I'm going to call that our final. Okay, so we have our mass of our original sample, and then we have our final mass. So it's asking us to solve for our final mass this time around. So first off, we need to determine how many half-lives have occurred, because remember, a half-life is how many times your sample has been halved. So to figure this out, we're going to take our total time, which is 151 years, divided by 30.2, and you should get an answer of 5. So in 151 years, our sample has gone through 5 half-lives. And remember, a half-life is how many times your sample has been halved. So if our original amount was 1, there's actually 2 ways you can solve this. The way I do it is I just take 1, and if I divide it by half 5 times. So 1 divided by 2 is 0.5, divided by 2 is 0.25, divided by 2 is 0.125, divided by 2, I can't do it in my head anymore, you get 0.0625, but we've only done it 1, 2, 3, 4 times, so we need to do it one more time, and we get 0.03125 grams. We have 4 significant figures here, 4 given to us in the problem, so we are done. And that's just the way I do it. It's really easy to check your work. We have gone through 1, 2, 3, 4, 5 half-lives, which is however many we calculated. There actually is a second way to do this step, so I'm going to show you how to do it really quick. To figure out how much sample you have left, you can actually, there's a little equation that you can do. You can take the mass of your original amount, and you can divide it by 2 times your exponent of the number of half-lives. So that way, we could have just done 1 divided by 2 to the 5th power which should also give us, if you do it on this calculator, 1 divided by 2 exponent 5. Okay, and we should have gotten 0.03125. Okay, so let's look at the next problem. The next problem is a little bit different. Instead of solving for our masses, we're actually going to be solving for time this time around. So it says, given that the half-life of carbon-14 is 5,730 years, consider a sample of fossilized wood that, when alive, would have contained 24 grams of carbon-14 and now contains 1.5 grams of carbon-14. How old is the sample? So again, I'm going to list my variables. So this is our total, no, this is our half-life of carbon-14. Okay, this is how much the wood, how much mass the wood had to start off with. So that would be our original mass. This is how much mass we have after the amount of time. So our final mass would have been 1.5 grams. And it is asking us to solve for our total time. So instead of finding out the number of half-lives first, we're going to have to deal with the masses first. And again, there are more than one way to do this, so I'm just going to show you the easiest way that I do this. You have to figure out how many times your sample has been halved. You cannot just go 25 divided by 1.5. You have to figure out how many times 2 goes into 25 before you get to 1.5. So I'm going to do the same thing as I did up here. I'm going to go 25 divided by 2. That gives us 12.5 divided by 2, which gives us 6.25, divided by 2, which gives us 3.125, divided by 2, and then we get 1.5625 grams. Now, we're not exactly at the 1.5 mark, but we're really, really close, so we're just going to assume that the sample has gone through a little bit more than 1, 2, 3, 4 half-lives. It's not quite to 1.5, so it's going to decay a little bit past the 4 half-life point, but we're just going to go do 4 half-lives with our calculations. So now we need to know how old the sample is. Well, if it takes 5,730 years to do 1 half-life, we're going to have to take that times 1, 2, 3, 4. So I'm going to do 5,730 times 4 to get 22,920 years. So in order for our sample of carbon-14 to decay from 24 to 1.5 grams, we are going to have to wait a time period of 22,920 years. Alright, so now I want you guys to try one all on your own. So if you would please pause my video for just a second and work through this sample all by yourself. I will put the answer up in just a minute and walk you guys through it again. Alright, so hopefully you guys have an answer now and you have tried to do this one on your own, so I'm going to walk you through this one. So this one says a 64 gram sample of germanium-66 is left undisturbed for 12.5 hours. At the end of that period, only 2 grams remains. What is the half-life of this material? So this time around, we're solving for what the half-life is. It gave us our total time, which is 12.5 hours. It gave us our original amount, which was 64 grams, and it gave us our final amount, which was 2 grams. Whenever you are given the masses first, we're going to have to, it's kind of going to be like the second problem we did over here, where we had to divide it by half and then solve for the time. So what I'm going to do is I'm going to take my sample of 64 grams, I'm going to divide it by 2 to get 32. Divide that by 2. You get 16. Divided by 2. So you get 8. I know I'm using calculator, but just to show you guys how to do it on your calculator. We have to keep going because we got to get all the way down to 2. So then we get to 4, another half-life. Then we get to 2, and we are to our final point. So it started off at 64 grams, and now we are down to 2 grams, which is what the problem told us that we did. So in order for it to go from 64 to 2, it has to go through 1, 2, 3, 4, 5 half-lives. Okay, so now that we know that we have gone through 5 half-lives and we know that it took us 12.5 hours to do this, we need to know how long one half-life is. So to figure this out, all you do is you take your total time and divide it by your half-life. So we're going to take 12.5 hours divided by 5, and you get 2.5 hours. So every single time the sample was halved, it took approximately 2.5 hours. So hopefully this process kind of helps you a little bit, shows you how to do it so that you're able to do your homework on your own.